In this lesson, I'll show you two examples on how to use the exponential density function. Question 1 reads, if f at t, which is defined by this piecewise function, gives the waiting time at a restaurant to receive your bill, what is the expected waiting time? To find the answer to this, all we have to do is locate mu. Mu represents the average, and notice that it's 8. Therefore, the average waiting time here is mu is equal to 8. And I'm assuming it's in minutes, but it doesn't really matter. In question number 2, we're asked, the time between major earthquakes in the Southern California region is a random variable with probability density function defined here, where t is measured in days. Find the probability that the time between a major earthquake and the next one is more than 365 days. So what we have to do is find the probability that t is greater than 365 days. Therefore, what we have to do is take the integral of our function between 365 days to infinity, and our function being 1 over 960 times e to the power of negative t over 960 dt. This is an improper integral because we have infinity as one of our bounds, so what we have to do is replace infinity with an arbitrary constant and take the limit later on in the question. So I'll set this equal to w, and this gives me the integral between 365 and w, pulling out 1 over 960 because that's a constant. No need to integrate that. E to the power of negative t over 960 dt. I'll do a u substitution here where I'll set this equal to u and take the derivative implicitly with respect to t. So I have du is equal to negative 1 over 960 dt. Solving for dt, I get negative 960 du. So I'll replace this part with u and replace this part with negative 960 du. This gives me the following, where I have 1 over 960, and remember this part has become 960 du with that negative. So I can pull that outside of the integral and place it right here, and look what happens. This number and this number cancel out, leaving us only with this negative out here. And the integrand now is e to the power of u du. This is now really easy to take the integral of. In fact, the integral of e to the power of u is simply e to the power of u, and replacing u back with what I set it as, negative t over 960. That is our integral. No need for a constant because this is a definite integral. We have to evaluate this at w, our upper bound, in 365. Now we will take the limit as t approaches w, and keep in mind that w is infinity. So if I replace this with infinity, a very large number, I would end up with e to the power of a very large number. And remember that very large number is negative, so e to the power of negative infinity gives us 0. Negative 0, which simply becomes 0. And we'll have to subtract this by whatever this is when evaluated at 365. So I have negative e to the power of negative 365 over 960, using my calculator, negative bracket negative e to the power of negative 365 over 960 gives us 0.683. 0.683. Let's interpret this for a moment. There is a 68% chance that the time between major earthquakes is more than 365 days. And there you have it. That is how to use the exponential density function. Make sure to watch part 2 for some more examples.